Okay, great. So I'll start getting the people into the room now. I'll start getting the people into the room. All right, we'll just give it a few more seconds and then we can begin the session today. All right, I think we can start. So thank you everyone for joining today's Opportunities for Energy Efficiency in Industry event that we're holding under IGEM. So I'd like to introduce our speakers for the day. So from Spark Sarco, we have Roslan, who's the technical manager. And just for background, Spark Sarco specializes in high quality products for the control and efficient use of steam, as well as other industrial fluids. We also have John Chin from Schneider Electric joining us as well. And he's the services operational marketing manager. So Schneider Electric provides energy and automation digital solutions for efficiency and sustainability. So its solutions combine energy technologies, real-time automation, software, and services. And then we have Eric Tan from GEA, who's the sales manager for emission control. And as background, GEA is one of the largest suppliers for food processing technologies, as well as a wide range of other industries. So they specialize in machinery, plants, as well as process technology and components. So just in terms of what the event will look like today, so we'll begin with a knowledge sharing session that will run up until 5:10 p.m. And here we will have Spark Sarcos presenting on their expertise in steam systems, followed by Schneider Electric speaking more about their industrial automation offerings, and then pass on to GEA to speak more about their waste heat recovery systems. And what will happen right after that is a virtual matchmaking session where we will have 3 breakout rooms and organize all of you into these rooms, just so that you can have a more personalized session with each of our suppliers. And you can use the session to talk about any challenges that you may be experiencing in your companies or any technology solutions that you're currently considering, and really use the session to ask our speakers any questions and seek advice for your challenges that you're facing. So it will run in terms of 3 15-minute sessions. So after every 15 minutes, we'll just rotate around our speakers so that you'll have the opportunity to engage with all of them. And right after the breakout session, we'll just bring you back to the main room for a quick feedback poll, and that will mark the end of today's session. So just in terms of housekeeping, so if you do have any questions while our speakers are talking during the knowledge sharing session, then feel free to just write it in the chat box and we will address them during the breakout sessions for you. But you'll also have the opportunity to directly ask our speakers any questions during the breakout room as well. And even if you don't have any questions, please do stick around for the breakout rooms, as our speakers will have further content and some additional case studies to also share with you as well. So just before handing over to Spirit Sarko, I'll just introduce the program that this event is being delivered by. So it's called the ASEAN Low Carbon Energy Program, and it's funded by the UK government. So we've been working on this program for about 2.5 years now, focused mainly on energy efficiency and green finance across Southeast Asia. So apart from our work with governments, we're also closely working with corporates on energy management, energy target setting, and providing technical assistance on that under this program. So if you have any questions on this, you can always reach out to us after the event as well. So with no further ado, I'll hand over to Roslan now to talk about Spirit Sarko. So over to you, Roslan.
Okay, let me share my screen first. Can you see the screen?
Yep, I can see it.
Okay, so I switch on the presentation mode. It's a bit slow. Okay. First of all, thank you for having me here. We and Spirit Sarko are glad to be here to share our experience, our journey in trying to achieve what we term in our company, we term it as a sustainability. Of course, here the topic is low carbon emission. As I think Kalani has mentioned, my name is Roslan. I've been with Spirit for quite some time already. I mean, almost retired with Spirit. I think I will retire with Spirit. I started my career in a palm oil mill, then proceeded to Spirex. So in the next 20 minutes, I'll be sharing you what Spirit is doing for sustainable part, and then later on maybe touch a bit on what we can assist anybody who wants to go for green, because there are a lot of room to do. When we're talking about Spirex, we cannot, I mean, if you're familiar with steam, then you know Spirex is part of steam. It's like unsplittable. I mean, you cannot split with Spirex, because we always see them as like we're talking Colgate with toothpaste. It's almost similar to that technology. So when you see steam, but for us, being in this business for 100 years already, we see this is a natural technology. And you can see steam is being used in everywhere in our everyday lives, from clothes, food, even in oil and gas, hospital, everywhere, even for cleaning, for medication. So it's a very, very important part of our process, I mean, manufacturing process. So when people think of steam, how can steam fit into low carbon? Because you need, all the while you are using fossil fuel to produce steam. And then in our investigation worldwide, we find, and then we search a surveys around worldwide, then we find that 68% of the factory that people will likely invest in green steam technology. And then we also find out that solar capacity, global solar capacity will be increased by 21%. And then the one more, I think, relevant to us today is the 10%. I mean, you can achieve an immediate energy saving through a better maintenance and just low cost improvement of steam system. That means there's a no-brainer. I mean, including housekeeping and then use better technology. So why steam? Because steam has been here for quite a while. We've been since Industrial Revolution in Europe in the 1600s. So the main reason why steam can last to this long is because it's the most efficient method of heat transfer. No other fluids can match it until today. So it's suit to everybody who wants to have a very efficient system. And then today you can see almost all industry are using steam. So when you see steam, then you can see Spirit there. So let me talk about a bit about Spirex. We are what we call world leader in the steam, commercial steam technology. Yeah? And then what we're doing that by supporting our customer in terms of technical and to face their energy challenges. Right? Sometimes to increase operational efficiency, and many times also is for safety. I mean, a lot of regulation that need to be complied with. And then if you look at our group, Spira is a UK-based company, MNC. We have three major divisions in our group. Yeah, Spira Malaysia is under this what we call steam specialty. So we're dealing a lot with steam, but in actually what we are dealing more on the what we call utility fluids. So you're talking about compressor, you're talking about chill water. Yeah? So all those in the utility section. And then we have a sister company who are using electric. We're talking about electric tracing, process heating using electric. And then finally, our Wasamalo, which is you use a special type of pump to provide clean clean delivery of product. So how big are we? We are not really big if you compare to bigger company in the world, but we are everywhere. Yeah, we have 62 operating companies. I mean, Spirex Malaysia is fully owned by Spirex UK. So there are 62 companies like us around across the globe. We have manufacturing site on all four continents except Africa. We don't have one in Africa, and Australia we don't have one in Australia. So all other companies we have a factory there. Direct employee 4,600. And our HQ is in the UK. Plus, you can see this include all the people, service engineer, admin staff, account, all those things. So total. And then one thing that I think we can be proud of is that our training center, we have 59 of those in the worldwide. And then this is where you can see our manufacturing. So Asia Pacific we will get our product from China, Shanghai, India, and some from Europe, even some from America and Brazil, Argentina. So it's all over. It's not just confined to one particular factory. We can get our product anywhere that suits the application. Okay, as Spirit Malaysia, we have been here about 41 years already. Yeah, since 1980. We have about 30 staff, so 12 sales and 4 service, and the rest is admin and operation. You can see if you are in the Glenmarie area, you can find that our office is just in the Tamasha industrial area. And then one thing that we do here is we have local stock. We have enough stock to support our customer in case of their maintenance MRO requirement. And then in terms of coverage, we cover almost every industry that is using steam. So in Malaysia, the main one will be palm oil and gas, dairies, food and beverage, breweries, glove, you have timber, you have tires, and many more that are using. So we cover across the industry in Malaysia. And this is our what we call STEAM Technology Center, which is actually a training center. And then we have courses that is HRDF approved. I mean, if you are a contributor to HRDF fund, you actually can attend our course and claim it from HRDF. Yeah? We are registered under SBL scheme. I think now we have a new scheme come out under the new HRDR corp. What's so special about our training center? Yeah, we have what we call a live steam demonstration rig. I mean, we actually have a boiler, even though we are not my factory. We are just training here, but we have boiler that produce live steam for demonstration purpose. And then we try, and if possible, to use transparent product to show how it works and how you can do the better maintenance. And then, of course, we have a fully equipped lecture room for all the audiovisual requirement. And then I think the last 2 years, it has been very, very, what we call, tough for industry with the lockdown. And then if you remember the early phase of the pandemic, there's a lot of shortage of masks, even what we call it, the breathing apparatus there. So Spira is proud that we actually, many of our associates worldwide actually participate in assist the government all over the world to produce this item, either by directly machine parts and product for the use, either PPE or for the emergency room, or to help a customer with improve the efficiency, because as you know, during the pandemic, the demand for food and basic item is increased tremendously. You can witness that in our glove industry, where their demand is triple and quadruple. So from 2 billion a year, they become like 6 billion a year, something like that, their turnover. So that means they have to ramp up their production to meet the demand very rapidly. And then that's where we able to assist them. And then our strategy actually include sustainability. We make it as a part of our strategy so that all of us Spirax-Sarco employee will be aware of what we need to do to help our planets. So our vision is to engineer more sustainable future by looking at our own process operating, then make sure that we are obeying every law, acting ethically, and then make sure that product that we produce, that we sell, do not really have major social or environmental impact. And then sustainable objectives, we commit to our resources to engineer a sustainable future. So if you look at the area that we focus, first, we also follow what UK government is doing. We target to have a net zero carbon emission by 2030. That is the group target. And then it takes a lot of effort because there's not much time left. Only 9 years left to achieve that. So we have to be aggressive. And then we must make sure that everything that we produce, that we sell, do not affect biodiversity and then and environment. And then we make sure that our product help not only our sustainability, but also our customer, our community sustainability. And then they include that we look at our supply chain. We must make sure that all people who supply to us also have the same goal, sustainability goal. And then, of course, we are part of the community. We will continue do what we can to help the community around us. And then, for example, the product that we sold last year, then we have a quick survey, quick calculation, and then we find that we managed to save almost 16 million carbon CO2 emission in 2020. And then if you look at the water, we save almost 80 million cubic meter of water just by helping our customer achieve that. If to put that in perspective, 15.8 million carbon dioxide per year is equal to you just stop 7.7 million cars. You take off 7.7 million cars from the road. So that's the impact of the carbon dioxide that we managed to achieve last year. And then same thing with water, you can see as if almost more than half a million people stop using water for 1 year. So that equivalent to the water saved there equivalent to almost 79 million. So we also realized that many of our customers, so they have their own sustainability objective. So they keep challenging us. So we also have to evolve ourselves to follow our customer challenges. And then it's our commitment to do all we can to sustain the sustainability. And then last but not least, we also part of the community, so we can do what we can to help our local community. We get involved in a lot of CSR. You can see here some of the pictures that's shown here. So talking about a bit about what we do, how we can achieve this. We operate by these three principles: expertise, solution, and sustainability. That means being in the business for 100 years, we have the experience and the expertise and the solution to maintain, to have the sustainability. So our core business, we are concentrated into 5 or 6 major areas. For example, if you are building new plants or you put a new extension, you want to expand your factory using steam. This is where we can help you with we can assist you in design, and then we can make sure that your system will be more efficient, sustainable, environmentally friendly, least impact to the environment. And then for the existing plant, what we can do now, we can offer you what we call steam system audit. Actually, it's like sending a doctor to check you. It's like you go for annual checkup to see what's wrong with your body. Even though you don't feel anything, but you still go for the checkup because sometimes you may not know what's wrong with your body. So the same thing with the existing steam system. Sometimes many plants think that they are okay already, but when we do detailed study of then we actually measure the efficiency, and then we can find a lot of improvement can be done to make it even more efficient. And then what we mean by engineered solution is that we, instead of just selling item loose, for example, GA is supplying heat exchanger. Instead just, if you buy the heat exchanger from GA, you still need to do all the piping, all the valve, all the fittings, everything. Then you have to do the engineering. But for Spirac, we offer the engineering. So when you buy, we don't have for example, heat exchanger, but we can take the heat exchanger and then we can engineer it so that when you buy this package, you just plug and play. You don't need to do anything more, and it will work to what your expectation, because we have the expertise and the knowledge to do that. And then I think now it's quite well. It used to be very popular in the oil and gas industry. They call it skid mounted, but now FMB also catching up, even palm oil also catching up. And then of course, this is a very ongoing, every day to day, non-stop. As long as your factory running, you need this thing. So we are there. You can see just we have enough stock to support you in your daily MRO activity. We also have service people that can go on site to do repair for you. And then finally, we offer knowledge to you so that with knowledge, you can use steam better in a safe way, in a more sustainable way, more efficient. So not only save you money, but also save the environment. Okay, again, this is just a repeat, but we say this is done because of this. The 1,200 people, the expertise, the knowledge. Yeah? We cannot do that without this thing. And then beside we can also customize costs to fit what your requirement. Yeah? Just because different industry will require different type of training, different type of knowledge. And then because we cover every industry that using steam, so we have that knowledge. And then just a bit about product. You can see all the product here is more on steam. Yeah, but of course, like I said, not only on steam, but also on the utility fluids. So this is what when I say package this is just an example of the package or the engineered solution. So you just plug and run. So talking about future, yeah, how can we make what we call concept today into a reality tomorrow? For example, because our goal is to reduce carbon emission, right? So all the while, if you see this is steam wasted, nothing can be done about it because the pressure is too low, 0.1 bar, even 0 bar. But whether you know or not, it contains a lot of energy, it still contains a lot of water. And we have a method to recover this thing using what we call exhaust vapor condenser. So we can recover this and reuse that in the process. If let's say you don't have any use for low pressure steam, because when you recover steam, you can recover low pressure. We also have a way to boost the pressure from low to medium pressure, yeah? So that steam can be used even in more process. This is a few of the projects we have done so far. Then you can see from all the steam plume coming out from the drain, from the chimney, everything. Our goal is to achieve zero emission. And then this engineered package solution, but there's one additional thing that because our goal is always sustainability, slow efficiency. For example, the control valve that we use, we incorporate what we call steam tight technology. That means it makes sure that this valve do not leak steam unnecessarily. Because, for example, if you use this for hotel or hospital, there are many times, let's say non-peak time, not people using this hot water. So when there's no low demand, so the heating requirement also low, then this valve required to be shut, completely shut. But the normal control valve will somehow leak steam because the method they use is a metal-to-metal seating. And then the best you can achieve with metal-to-metal seating is class 4. What we term is as class 4 leakage rate. If you want to go better, then you have to spend more. I mean, you can go class 5 by using Starlight, for example, fine foliage sheet. But the steam technology is much cheaper than that. And then this package is actually to produce clean steam for food industry, also for pharmaceutical industry. Because normal steam that we get from boiler is not suitable for direct contact with food or medicine. So you need to generate steam from pure water. Okay, what we're working now, I think this is our group project. For example, we see the trend in Europe, in the US is going for hydrogen. We see that. So, but to generate hydrogen, we see the using another renewable energy. For example, we are using wind turbine to generate electricity to do the hydrolysis, create oxygen, then condense this oxygen will be used to burn to produce steam in the boiler. So that means burner technology has to be modified to suit this new method. Also, creating thermal storage for home of a factory. So if you have renewable energy available, as for example, solar, wind, but they are not what we call it inflexible in terms of, so if you can store them and then use them to generate steam whenever it's needed, that will be a lot benefit to us in terms of sustainability. So this is an ongoing project. We work with third party. So it's not that far off from become a reality. So this is the end because I almost exceed my time. So if you have anything, you can contact us. You can Google, you can go website. Okay, that's it for me. So I think if you have any question, I'll see you in the break room later on. Thank you.
Many thanks, Ruslan. So now we can hand over to John from Schneider Electric. So over to you, John, to share your slides.
Right, thank you, Kalyani. So just give me a moment to share my screen. Oops, I cannot share. Yeah, I need Ruslan to unshare your screen first. All right. Okay. All right, so again, good afternoon, everyone. So I'm John, I'm from Schneider Electric. So today I will briefly, take everyone over, for 20 minutes about efficiency, about equipment performance, and how we keep it running today. So when we talk about efficiency today, it's not just about power and energy efficiency, but it's really about how to keep our asset, our equipment running, and we prevent downtime. Especially in the digital age today, as we've seen in Malaysia, we have accelerated our digital growth or the digital maturity by at least 5 years in the short 2 periods of a pandemic period. So we can see that there is a lot of connected point. We have a lot of digital economy grooming. We have a lot of online portal selling things over here. But what actually powering up this digital portal behind this will be the power distribution system, and whereby if you think carefully today, a lot of the digital only happens at the end product, but not in our power distribution infrastructures. So in this 20 minutes, I will take you through a few of the topics today, which is inclusive of the electrical distributions equipment, the trend of electrical distribution, how to maximize your equipment performance, and of course, we can do the Q&A during our breakout sessions. So with that, I'll quickly go into the first sections over here, which is electrical distribution equipment. Of course, I will not be going through what are the equipments that we have today, what are the breakers, the transformer, and so on and so forth. I'm pretty sure most of us are participating in this talk today, already know most of the common equipment out there. But what I wanted to bring attention to you today, is how are they impacting power distribution today? So if you look at these two circle charts over here, which is the source from the FM Global Insurance Report. So we carefully pick insurance report because they know very well each time when there is a claim of the building accidents or incidences, it will always relate back to electrical systems. So if you see from the chart over here, accident caused by cause, 64% are actually caused by fire. And out of these 64% of fire, the primary cause is actually electrical distribution system. So this is a very, very alarming status, and this is something that we have to be aware of. Most of the time, we already know, most of the time, some of the older shops, suddenly they caught a fire and then suddenly they spark. It must usually start with two identifiable places. If it's a household, it might be a gas pipeline or a gas tank. If it's a commercial building, mostly it will be caused by the electrical system or the circuitry. So having known this, how would it impact in terms of the cost to us over here? So when we talk about cost over here, it's not just about the loss of a property and in a worst case, loss of a human life, but it's about the disruption of the business and reputations that we're suffering over here. So again, this is an FM Global Insurance Report source over here. And in US alone, based on the statistics over here, it's estimated, for this one particular year, almost $800 million are lost due to the lack of electrical maintenance as contributing to how the business fail and also the loss of the property. So while we look at this gigantic and also humongous amount over here, so how do we derive back? Now I'm bringing you back to a focus, right, to a key 4 or 5 areas over here, right, that is going to contribute to electrical fire today that you might need to pay attention to your building equipment. Starting very, very innocently, circuit breaker. All right, so a lot of us will think that circuit breaker are designed to protect us against fire, against short circuits, against human loss of life. But in the end, right, because of the lack of maintenance and because we do not know what is the health of the circuit breaker, it might pose you more risk than you think. And of course, the second will be transformer. Coming later will be cable, bus bar, miscellaneous, and of course, electrical motor. So electrical fire has been more and more common right now. So one of the greatest contribution to it, right, will be power quality, which I will also be briefly covering during my talk later on. Because of the electronics and also the digital age that we are going through right now. So I don't believe there is any buildings in Malaysia, let's talk about Malaysia, commercial one, all right, that is free from electronics component. So long as there is electronic components and also other efficiency motor control system, there will definitely be one main culprit, which is harmonics. So I will talk a little bit more about harmonics later on. So knowing this equipment over here, right, if you notice, right, none of this equipment, if your property or if your equipment is installed like back to 5 or 10 years ago, right, almost none of them are properly monitored. Right? In Malaysia, unfortunately, we are still very dependent on one measuring device to monitor our facility, which is the digital power meters. So oncoming, I will also tell you why it is not adequate anymore. All right. So the second topic that I want to present to everyone today will be the trend in electrical distributions. So a lot has been happening, all right? We see a lot of green energy, and then we see that our panel has presented about steam power. We have talked about the original or the traditional conventional hydroelectric dams and also some steam co-generations over here. But what is really, right, translating in the whole picture today will be how the future network will look like. Right, for Malaysia, we are starting to see this, but for the other country, right, we're already seeing a lot of accelerations. First thing first, right, is that by 2025, right, there will be 10 times more digital core connecting devices. So what does it mean by 10 times more? Roughly about last year, we have about 30 billion connected devices. So by 2025, we would see 300 billion connected devices. So what does this translate to? It translates to more and higher power consumption. So in order to mitigate that, right, so a lot of the country, including Malaysia, is already, right, starting to go into green means of energy generation so that we can be 30% more effective, all right, because we need to use 30% more power, and we have to cut down at least our carbon footprint by 50% if we intend to have our more of our generation to live on this planet. All right, and of course, if you see the trend over here, electric vehicles has been a growing trend also. All right, so by 2030, we are predicting that more than half of the vehicle seen on the road will be electric vehicle. And lastly, it will always be required, right, to be power up 100% of the time. Just recently, not too long ago, Facebook, I think, social media, Facebook, right, has disruption in the middle of the night, and it created so much of the chaos. So imagine if your business is suffering the same, the same problem, how much disruptions or how much losses you will have to deal with. So having noticed over here, right, this is a new grid system, right, that is happening today. So if you see, right, in the electrical distribution system, it has become more and more complex with the with the passive feed-in, all right, self-generation from solar pump or also wind turbine, which we expect, right, by 2030, more than 70%, right, of the commercial building or residential building, right, will have these power generations, right, to feed back either to the grid or for their own consumptions. So this means to say, right, in terms of a DC component, is no longer just electronic, but it can also be a DC storage battery that is going to further complicate the power distribution system. So in a nutshell, what we see today is that the older generations of power distributions that you have designed for a building might not be able to cater even for power consumptions or for power generations, right, that you would want to move on in the next 5 years to come. So one thing, of course, if you notice from the slides over here, power management system has become so common today. All right, so most of the buildings have BMS system, most of the buildings have power management system, but how to connect back to this equipment over here will be the key. All right, so in this decentralized power distribution system over here, right, we are really looking into, we really need to look into how we redesign and also how we want to upgrade our existing facility so that the building can be more sustainable and also drive for a future installations. So this is a nutshell, right, or an overview of how the electrical systems are transforming. All right, so I'm not sure how many of you are coming from design background, but in the simplified moment over here, you can look at the bricks, right, in blue color on the right-hand side. So this is all new component and also some of the not conventional components that you might see during the designs of the building, or if you have an existing building who has aged for some time, right, this might be the components that you would want to consider adding in. For one thing is that we talk about 100% uptime, so backup power is almost very important. We talk about green building, we talk about sustainability and energy efficiency, solar power and also wind power is also very critical in this part. And of course, with this in mind, right, you still need to have an energy storage, and of course, EV charger is becoming a trend. And all this, right, will contribute to power quality issue, which is why you need to have a power factor compensation system or an active harmonic filters for a very least. So coupled in, the must-have will be a smart meter, so as we can track all the pointers, right, and also rebalance your network so that we have more energy efficiency. Okay. Moving on is that what we did not realize or we did not pay attention to is that our equipment is actually getting smarter, not just better, but also smarter. In this case over here, right, there is a lot of innovation, especially from Schneider. We have already come up with circuit breakers that talks back to you, that tells you what are their own condition, whether they are risk, whether they are posing risk to your facility, and whether they require any maintenance services or not to better manage your OPEX. All right. The more complex the system you have in your building, which is unavoidable, if you want it to be future-proof and also technology-proof, is unavoidable. But the more complicated it becomes, right, the higher the OPEX is, will be to maintain them. And this is where we have to get a little bit more innovative. We have to know, right, what exactly we want to maintain and service, right? Not just doing a regular preventive maintenance, but we have to move on to something called as the conditional-based maintenance. This would help at least save 20% of your OPEX cost. So when we talk about equipment getting smarter, we're also talking about emergent technology with this equipment itself. So most of the time over here, we have so many complicated equipments in your facilities over here, and you might not be able to hire a team of 100 people or 50 people, right, to be specialized in all these equipment itself. But there is a definite need for you to ensure that the business keep running, the production keep going. So this is where we have augmented reality. This is for one thing, right, is to help you to get assistance, right, from the OEM experts, such as from Schneider, if it's for drive or any component from us. And from this augmented reality over here, right, it's really going to replace all your paper manual, all your schematic design. You just need to put on the VR glasses, or you can even use your pads or tabs or even smartphone, right, to scan the component, and all the diagnostics will come up, and it will also, right, create a step-by-step troubleshoot for you. So this is how technology is mixing in, right, into making life easier and also less risky. So in terms of monitoring over here, we talk about remote monitoring. So we are no longer talking about just on-site monitoring over here. The reasons why we have to have remote monitoring is because pandemic has taught us a very good lessons. So most of the time, even though we know that your production line or your building might have a risk because of a certain readings and so on, right, you just can't get back to the facility, at least not on time. All right. So with remote monitoring over here, right, supported by our bureau, which is our specialized team, right, in doing the monitoring and analysis for you 24/7, you can actually access, right, to your site anywhere, anytime in the world. So it become a reality to support the new trend, which is work from home. Right nowadays, I have read somewhere over the news earlier on, right, our new workforce, which is the the millennials and those oncoming new generations. I'm pretty sure they will not be too fancy in working from office kind of a setup. They will prefer more on working from home. So with remote monitoring and also bureau services over here, this is supported. All right. So moving on, we have already done about trend electrical distributions. Moving on is that the multi-million question is, how do we maximize our equipment performance? After all, you have already invested a lot of capex and you are spending annually quite a lot of a sum in order to maintain those equipment itself. So how do we maximize the equipment performance? For one thing for sure is that we have to keep them running and running at an optimized performance, so that first thing, you do not have a risk of power disruption, and secondly, right, the energy efficiency is much higher and you don't have any problem. So one of the things to do, right, is obviously one of the choice will be to have a real-time power monitoring over here. So what I mentioned over here is real-time. All right, so I'm sure you will say that, okay, John, this is nothing new. Most of the building has already real-time power monitoring. Yes, correct. But then what about the meaningful insight from this data? All right, most of us today, right, garners a lot of data. We collect data every maybe 20 milliseconds in some critical data center, say, for example, or every second, or every 2 seconds, or every 5 seconds. So by the end of the day, you might have generated 1 gigabyte of data in an Excel format. But the question is, what do you do with the data? What does the data tell you? How does the data tell you? Or are we today just using the power monitoring system, right, to just see which one is online and which one is offline? If you are doing that, then we're not utilizing the full potential of the system that you have in your building. Because trust me, if you fully utilize this potential over here, there is so much of a room for improvement that you can do that will drive much lower OPEX for you. The next thing that we need to do, right, will be electrical thermal monitoring. This is more on the addressing the risk of power disruptions and also fire risk. So most of the time, this is a common thing when we have electric, what they call a transfer from one point to one point to support to a load, there will always be heat generation. Now, this heat generation is not just one of the problems, but because of the frequency of the electricity, right, there is also a problem of the hotspots on loose connections. Now, imagine you have a building, let's say not too big, 30 stories, all right, with about 20,000 square feet of build-up for each of the layers over here. So you can imagine how many cables or how long cables, how many equipments that you have to scan manually if you are to do it. So therefore, right, for example, Schneider Electric, we have come up with remote thermal sensor that is also coupling, right, with the characteristics of the equipment itself and also constantly measure. The key point over here is constantly measure at real time. What are the temperature of this particular cable, busway, transformer, or any cubicle of your MVLV distribution board? By having this temperature measured and combined with the readings from the power meter, then we actually know whether you have a problem with the particular equipment or not, and what are the potential risks associated to it. So this is something, as we call it, as analytic, to provide insightful or meaningful insight so that we can act on it before anything happens. So bear in mind over here, if we are to hire external contractor or even to hire a permanent FM to do thermal scanning, really, right, it will take forever and the data will not be live and it will cost even more. All right, so this is something that which is very important to help address a fire risk and also unplanned downtime. So moving on over here, right, like what I explained earlier on, why thermal monitoring can help prevent electrical fire. Remember, 22% of the workplace fire are actually caused by electrical fire. 25% of major electrical failure is actually due to loose connection or faulty connection. So this is why thermal sensor will actually help you avoid that. And of course, for every $1 spent on monitoring over here, right, there is a $10 of a risk prevention of equipment damage. So one of the examples, some of the examples that I pretty much want to take it over here, right, will be some of the chemical plant and also data center who has actually benefited from the thermal monitoring over here. So I'm putting more emphasis on this thermal monitoring because to me, if you ask me today, what is the major contributions to energy efficiency? Definitely, I would say usage. But what is the hidden risk today will be the power disruptions that you might not see. In a worst case situation, we will have fire. But in a lighter case of a situation, we might suffer a few hours or a few days of a downtime. And those downtime is very critical because we're in digital age. We can no longer avoid any downtime. All right. So with that, of course, another part over here, else the thermal monitoring will be the breaker settings today. So breaker setting is not new. In Malaysia, right, we use something called as a switch disconnector, not a full ACB, all right? And the tripping is actually controlled by protection relay or OCF. And some people might call it OCF over here. Now, the problem over here is that this OCF might not be integrated into your power management software. So means to say every time after servicing or every time you add in a new load or every time you remove a different load, the settings actually varies. And the preset settings might not be secure enough or safe enough to protect the building and human. Right. So this is where, right, we will always advise to connect OCF or your protection relay back to your power monitoring system, or at very least, right, start to use breakers with integrated trip unit. Because with breakers that is incorporated with trip unit over here, the whole breaker can be connected back to your PMS system. And from there, you can not only just measure and also reset your setting, which is according to the current usage and the current needs of the protection, but also track the health of the breaker itself. Now, tracking the health of the breaker is very, very critical, right? So we all know when we do annual servicings, we rack in, we rack out, we test, and so on and so forth. But then we do not know whether the contact, the bushings, or anything inside, whether they are still requires servicings or not. And one of the wastage over here is that most of the time when we do predictive maintenance, we'll do it for all the breakers or all the panels that we have. But what if we imagine, right, at that particular period of the time, there is only 2 out of 40 breakers that you need to service? We are unnecessarily spending more on the unrequired services. All right, so this is where it becomes very important to digitize your power distribution system. All right, aging wear and tear, like what I mentioned earlier on. So this is where it can also be captured by the PMS system if you use a fully enabled trip unit circuit breaker and connect them back to your PMS system. So not over here is that the environment also contribute to how's the electrical wears and how's the breaker age. So this is where, right, in Schneider, we also have something called the environmental sensor to detect whether the environments of the housings or the rooms that house the equipment over here, right, it's actually contributing or accelerating to the aging of the equipment. And if they are, by how soon? So one of the good predictors that I've seen so far is that they will advise you, dear Mr. Facility Manager, you will have 8,000 more hours before your transformer will start to fail you. So please or kindly source for alternative. If it's fixable, they will recommend you. Perhaps you would need to do a servicing for this particular part, so on and so forth. All right. So this is a sample of electrical wear. All right. Arc shoot wear, main contact wear, and breaker aging in terms of the chassis and mechanism, in terms of the connection, and of course electronics. All right. They also age, even though they are very accurate, but they also age. All right. So is your facility ready for power outage? So I'm not talking so much of energy efficiency because energy efficiency encompasses 2 scopes over here. One is how we effectively use the energy, which I think you have already heard a lot about it. And of course, we can discuss more during our breakout session. But what I really want to point over here is that, are you ready for power outages? If it's not, are you doing something about it today? All right, so this is a statistic provided by Blue Pillar. All right, there is approximately more than 265,000 of power outages increased since 1984, before digital time. All right, 20 to 30% of generator fails to start in an outage. This is very, very critical. And 23%, I use hospital over here because life is the matter most. is actually non-compliances in terms of their standby power. All right, so when we talk about the topic of generators over here, so before we talk about that, right, let's look at how the revenue per hour and also the revenue per employee hours is affecting your business. This is, of course, a statistics provided by Blue Pillar. If there is, unfortunately, an event of a power outages over here. So monitoring and testing your backup power supply will be the next topic, because sometimes, whether you like it or not, you still will have experienced what I call it, power outages. But when you have power outages today, how sure are you that your backup power can turn up? How regular your testing is being conducted? And how sure after testing that everything works fine? So this is where, right, the generator performance monitoring can also be incorporated into your power monitoring system in order to ensure that your generator or backup power is always in a tip-top condition, to ensure that whenever, touch wood, anything happen, you are still able to recover certain part of your business, at least the most essential and the critical one. Okay. So UPS performance monitoring as well. Most of us are using UPS today, but some of the time, right, you might be wondering, will my UPS last forever? What is my UPS status right now? So what is my battery status right now? So this is where, right, you can also incorporate this as a risk mitigation into your power monitoring solutions. And of course, last but not least, power quality equipment monitoring. All right, this is where, right, primarily of most of the power quality issue originate from harmonics. So we are using a lot of electronics. We're in digital age. Harmonics is something that is unavoidable, but the mitigation is very, very important, because the damage of harmonics is very, very huge if it's left unattended. So it should be more common for us to install active harmonic filter. And trust me, your investment to active harmonic filter, although it can be reasonably a little bit more pricey, but it's really worth it. All right. So all in all, right, with all this equipment, power monitoring, so on, right, added up together, then you will have a smart devices plus real-time continuous monitoring, and very important, and also the key point, analytics. So analytics is a service that offered by Schneider Electric, where we have a bureau located in India and also Europe to support your business in monitoring, right, your data 24/7, and also prompt you with any alert and also mitigation proposal should there be a need to it. With this in mind over here, what we will be getting for your building will be a reliable operation and an efficient maintenance over here. So when we have both of these reliable operations and efficient maintenance, we're pretty much lowering the risk to almost zero. I won't say zero, and I can't say zero, but almost zero. And at the same time, at very least, save your OPEX cost by 20%. All right, so with that in mind, that will be my last slide for today. So how much could your equipment save you in terms of a fuel shutdown, in terms of a lower improved productivity, improve of a less downtime, in terms of a lower utility bills, so on and so forth? This might be a questions that you might want to start to ponder. All right, and of course, if you have more questions regarding this topic over here, you can always contact myself or Schneider Electric. We'll be more than happy to start your journey with consulting. All right, so we are also offering obsolescence profile consulting that is for free, that is for Grab. So you can always contact me through Kalyani, of course. Then we can actually look up how to speed up your accelerations or your digital journey via audits. All right, with that, thank you everyone. Over to you, Kalyani.
Thanks very much, John, for that. So we'll have our last speaker now. So I'll hand over to Eric from GEA to start sharing slides.
Okay, yeah, good afternoon. Let me share my screen here. Okay, so can you all see my screen?
Yes, just make it on presentation
Put
mode.
it in presentation
Perfect.
mode. Okay. Okay. Yeah. Good afternoon again to everyone. So yeah, welcome to today's talk for this workshop, the opportunity for energy efficiency. So today I would like to introduce myself a little bit again. That this is Eric Tan from GIA Malaysia. So today I'm going to share a little bit about this waste heat recovery with the ORC technology, and that is related to process energy efficiency, which I believe is in line with our today workshop topic. So let me bring you around to just have a quick look at what is GEA and what are they doing before I start deep dive more into the waste heat recovery. So here we can see a history of the GEA group and also GEA Bischoff, who is the affiliate of GEA group that focus on the emission control business. So GEA Group itself, we started on the business or founded in 1881, which is about 140 years from, up to now. And GEA Bischoff itself has been established in 1910. GEA, as what we have been introduced earlier on today, that GEA is one of the world's largest system supplier for food, beverage, and pharma sectors. So here are some of the performance figures for the company, for the group for year 2020. As you can see that compared to year 2019, we are so-called lucky that our business is not very, getting any kind of impact from this COVID. We are MNC, so we have a business everywhere worldwide. So if you look at the Asia Pacific, you can see that the Asia Pacific has been quite important region for the company, that we have about 3,000 people out of the total 18,000 people of the group. And we made in 2020 about a 1 billion euro business, which almost to 1/4 of the total group business. So here is trying to just illustrate or trying to tell a little bit more that where we are focused for this GEA Bischoff. So basically we are focusing in this 6 industry, moving from the left to the right, that we are covering the non-ferrous, chemical, iron and steel, cement, glass, and last the energy sector. And among of the 6 industry, we actually have offering the energy recovery, which is the iron, steel, cement, and glass. So here you can see what kind of solution that we can bring to the industry, and as well as the technology that own in-house within GEA Bischoff. So from the clockwise, from the top, we have this wet solution that depending on this scrubber, in various type, that you have Venturi, jet, or submerged type of a scrubber. And we also offering some gas conditioning equipment, which covering this gas cooler, quencher, evap cooler. Then we have cyclone columns, spray dryer, absorber, as well as the waste heat recovery, which is our topic today. And we have a EP absorber, catalyst reactor, which normally you might know heard about this in the name of SCR. And we have a fabric filter, which also can be in a ceramic candle filter form. And last, we have one of the oldest technology, what we call the electrostatic precipitator, or in short, normally people call it ESP. And this ESP we offering in 2 situation or 2 solution, in either the dry solution or the wet solution for different application. So on the left hand side, that we have listed out some of the solution that we can actually offering to the industry with utilizing the technology that we have. And at the last, you can see the energy recovery. So in the company or GEA Bischoff, as we are more focused on the emission control or environment business, so energy recovery has been one of our focus recently, about a decade ago. So, okay, now, that's all about GEA Group and GEA Bischoff. Now let's look at the ORC waste heat recovery. So this is a result of an analysis that conducted by the ORC World Organization. That is not the latest one. That the study is covering from 1997 up to 2016, with some installation which still in construction at that time. So this slide is trying, the bar chart on the left-hand side is trying to illustrate the install ORC capacity per year and per application worldwide, that covering three application. The first one is the heat recovery, and also we have the solar and biomass. So heat recovery is represented by the blue color bar, that you can see that it's getting more and more important for this ORC application. And on the right hand side, you have the bar chart, the pie chart, that you can see for heat recovery application alone, that the total install capacity up to 2016 January, that we have the about 350 megawatt power. That what are the industry that actually use a lot of or adopt a lot of this technology. So as you can see, diesel engine or gas turbine has been the key user of this ORC technology. But beside that, we also have others, for example, like the waste to energy, which almost like 6%. Then we have a primary or fabricated metals, quite significant, 7%. And you have glass, you have cement and lime. These are few key in industry that adopted a lot on this ORC waste heat recovery. Okay, so now look at why are we important, or why are we interested to know about this waste heat recovery or using this ORC. So there are a few reasons, and here I'm just listed out a few of the key one. So the first one is to increase the efficiency of the plant, the process of the plant, that we trying to recover the energy which otherwise will be, I would say, I'm not saying unused, but just wasted. And also that we trying also to use to decrease our OPEX by doing this waste heat recovery. Last is to decrease the carbon dioxide emission, which in line with the United Agenda 2030. So how can we do the waste heat recovery? So it's going through by the transfer the heat from gas to a thermal oil system. Then the heat that we have collected from the waste gas, then we use it either to generate the electricity through the ORC, or we use to heat up water for district heating network, but this is more for the Western country. Then we can also shift the heat from one process to another, or in certain cases, like for instance, for the glass production, we could have the waste heat recovery unit coupled with a chiller for the cooling purpose. So here, let's look at the on the left, this basic configuration of a fully integrated energy recovery system. The ORC module consists of a turbine with an organic fluid and heat exchanger, as well as a heat dissipation system. So waste heat recovery unit is represented by the red color box here, that they are the heat exchanger to transfer heat from the gas to the thermal oil, or through the water circuit as well. So installation of two waste heat recovery unit only makes sense if the inlet temperature of the gases is high enough. So we were expected the waste gas normally from the furnace of the industrial process. So the heat transfer from the gas to the heat exchanger medium, it could be a thermal oil or it could be a water circuit. Then the heat exchange medium will pass through the tube bundle, and the tube bundle is usually constructed in the form of a drawer type, which give a benefit of easy retractable and installable, because this is a wear and tear part that we expect there is a lifetime that you will need to replace after a certain life of service. The ORC module included an organic working fluid in a closed circuit. So this is a closed circuit that there will be no refill of this organic fluid from time to time until we detected the organic fluid degrading. Electrical power is produced in a generator powered by a low pressure turbine. And being a compact and self-contained unit, the ORC module only required quite relatively a small building or space. Compared to steam system, the ORC module is more easier to operate and required also relatively low maintenance. Also, the ORC process is able to handle operation at the reduced workload very well. I think this is one of the key benefit or features of this ORC, that it can go from full load until a very low load, for example, about 10% of the design workload. So this is how the ORC module look like, and normally the entire ORC module will be constructed and installed at site on a skid mounted. So ORC model is composed of numbers of skid containing all the ORC component and accessory. And as you can see here, that we have illustrated the entire system. We can split it into three parts that we can put it together at site easily, and that also easier for transportation and as well as the site installation time. Here, I would like to bring you through a little bit on a comparison of the steam cycle or organic Rankine cycle, meaning to say that waste heat the heat that we retracted or recover from the waste let's say the flue gas, that you can either actually recover the heat and generate power, electric power, through a steam cycle or an organic cycle. So here we do I would say a quick comparison. So we look at different angle of the comparison for the comparison. The first one will be the thermodynamic features and the consequences. So for the steam cycle, we were expecting or there will be a need of superheating, and that is not the case in ORC. Then in the steam cycle, you will have the risk of the turbine plate erosion due to the possible liquid formation during the expansion stage. But that is not the case in organic ORC as well. Then high enthalpy drop, turbine will have to design with the high stage numbers, as you can see in the table here. Then ORC is on the other end, that the turbine is only required a low stage number. Then in terms of operation and maintenance costs, steam turbine, you will have the water treatment. But then for this ORC that run on the organic fluid, is a water-free system. Then in the steam cycle, you will need a highly skilled personnel. But for ORC, we only need a minimum operation and maintenance cost. Then for the steam side, that periodic major overhaul is required. For ORC, not really any major overhaul. Still, there will be some routine kind of maintenance, and the ORC system can be operated completely automatic. Then the last about other features that between the steam cycle and ORC that the steam cycle will have low flexibility, which will give the significantly low performance at a partial load. But on the case of ORC, as I mentioned earlier, that they are quite highly flexible, where we can operate widely from 10% up to 110% range. Then of course, the steam cycle have some pro and con, and in this case, they are convenient for the large plant or larger plant at a higher temperature. For this the ORC, one of the things that we highlight here is the high availability. Average, we are talking about more than 98%. So let's look at what kind of output option that we have by recover the heat from your process. So I took the example in the glass industry, that we have the flue gases from the furnace at about 600 degrees C. We put two units of waste heat recovery, one on the raw gas and the other one on the clean gas. Raw gas and clean gas, the difference is that the flue gas coming from the furnace will have some dust and other pollutant. So this waste heat recovery unit will take the raw gas, and this is a more, I would say, a purified gases with temperature, and both are connected to a thermal oil circuit. So the gases coming out from the second waste heat recovery and connected to the ID fan and stack will have a temperature about 180 degrees C. So in this case, through the ORC module, we will be able to produce main on the electricity, and the other option is to produce the compressed air by coupling the ORC turbine to the compressor. So the other alternative is, beside the compressed air that can be produced from this ORC or this waste heat recovery system, is that electricity, and in this case, we have the space heating and also other process uses. As I mentioned, that probably that is not the common case for our tropical country. That will be more important or more useful for the Western country. So in this case, they are slightly different, that we are still having the ORC to produce electricity, but in this case, we have the heat exchanger connected to the thermal oil circuit, and as well as we still producing the space heating and also for other processes use. Yeah, this will be the last option, that the output option from this ORC. That in this case, you will see is different, that the ORC is no longer involved here, but again, we will replace it with the oil fire boiler, and with the boiler, we are connected to a chiller, and then there will be a refrigerated water circuit, so that you will provide some cooling for your offices and others processes. So these are all the possible option of the output of this ORC or the waste heat recovery system. Let's look at one of the example that in the glass productions. This is a plant owned by Saint-Gobain, a French company or group, that we have put up an energy recovery system with the ORC for their flat glass production line. This is a plant in Pisa, Italy. So for what we have delivered here is a waste heat recovery on the clean gas side. That is after all our emission control solution. And we have also provide a thermal oil system here, ORC module with an air compressor, thermal oil heat exchanger for heat water production for ambient heating, cooling tower system. So this is a turnkey project for GEA, and the plant has been started up since 2019 July. So here I'll just give you a assumption that, assuming that the German power makes a very conservative assumption of 8,000 operating hour per annum, that this system actually able to save up to 2,600 ton carbon dioxide emission per year. So what we can gain from this the energy recovery system is that we will have 4,450 kilowatt thermal power, and this will be able to produce up to 927 kilowatt gross electric power, also up to 78 normal meter cube per minute of this compressed air at a 7 bar, and also up to 57 kilo per second of hot water at 70 to 90 degrees C. So this is the waste heat recovery unit that installed in this Pisa, Italy plant. So we have this waste heat recovery integrated together with the emission control gas cleaning plant as well. So beside the glass, there's also the application in cement. So in this case, the waste heat recovery putting up to retract or to recover the heat from two different processes in cement. One is from the kiln preheater tower, and the other one is from the clinker cooler. So as you can see here, what is in the circle is the building of the ORC turbine and also the cooling system for the ORC turbine. So yeah, we are coming almost to the end. Yeah, hopefully I do not exceed the time too much. Yeah, let me give you a few takeaways for today's sharing. So the first one is waste heat recovery, I would say, is no doubt as one of the process energy efficiency solution for industry that particularly involve high pressure processes. I mean, for example, for those that having the furnaces for their process. Second is the waste heat recovery with this ORC is a better option from thermodynamic cycle operation and maintenance cost perspective compared to the steam cycle, particularly for power generation of a smaller capacity range. I would say in the range of anything below 10 megawatt. Last, waste heat recovery is not only help to increase the process energy efficiency, but also to reduce the carbon emission that has been one of the big global climate change challenge that we are all facing today. So I think that's all from my side today, and thank you for your time. Yeah, I will pass back the stage to the organizer.
Thanks very much, Eric, for that. So now I will just stop our live stream